let's walk through how to get started on Hardy-Weinberg problems. So the first thing that you need to determine is what information you're given in the problem. So there are generally three types of information you're going to be given. You're going to either be given the number of alleles, so this is going to be an allele count, or they're going to give you the number of individuals with a particular phenotype, which you can then infer a genotype frequency from. Or you're going to be given the allele frequency outright. So you have to look at the problem and think about what they're giving you and what they're asking. So you have to be able to pick up on some key words. If it's a phenotype, that's kind of an easy one. They're going to give you a characteristic of the organism. They're going to say the organism has brown fur or red eyes or bushy tail. They're going to give you something about the individual. And then you can infer the genotype from there. If you're given an allele frequency, this is probably the most obvious one because the problem is probably going to say the allele frequency of the recessive allele is, and then you know that you're given an allele frequency. The number of alleles question is a little bit harder. So you'll probably be given a number of individuals maybe, and you might have to infer the number of alleles from the number of individuals with a particular trait, or you might just be told in a given population you have X number of alleles. In my class, the most common way that I ask this question is probably giving you a phenotype. And my reason for doing this is students often mix up whether or not they're given Q or Q squared. So I'll talk about that one in a minute. Now I like to do this because it lets me know if you truly understand whether or not you're being given a phenotype or an allele frequency. The least common question I ask is a question where it starts out with the allele frequency, and the reason is that you don't really have to do much calculating. You don't have to know what you're starting with because I give it to you. So that's the least likely. It doesn't mean it won't happen though. So let's start with the being given the number, a total number of alleles. So this might say something like, in a population of birds, the number of long feathered tail alleles is 120, and there are 300 individuals in the population, or something to that effect. Now there's a couple things you have to think about here. You have to think about if you are given actual alleles or if you're given individuals. If you're given individuals, you have to calculate alleles based on the idea that each individual has 2 alleles. If you refer to the screencast videos I did, some Hardy-Weinberg problems, there's actually a problem there where I calculate the number of alleles given. So I'm not going to do problems here. I'm just giving you a flow chart of how you can work through these. So determine if you are given a number of alleles. After you decide that you've been given a number of alleles, you're going to want to determine if you've been given a number of dominant or recessive alleles, because this is going to determine which value you start with. Let's say you're given a value for the number of recessive alleles. If you're given a number of alleles, you can directly calculate your P or your Q. So if you're given recessive alleles, you're going to calculate the frequency of a recessive allele. Now calculating a frequency just means you're going to divide the total number of a particular group by the total. So in this case, we would divide the number of recessive alleles that we have in a population by the total number of all alleles in the population for a given trait. A frequency is going to be expressed as a decimal, and it should always be less than 1. It might equal 1, but can never be more than 1. After you calculate the frequency of the recessive allele, or your P value, you can then use the idea that P plus Q equals 1, because this is a frequency. Everything has to add up to 1 here. You might be given the dominant alleles. Same thing, you're going to calculate P this time. P is just the frequency of the dominant allele. So P is going to be equal to the number of dominant alleles in the population divided by the total number of alleles in the population. Again, this is a frequency, so it's going to be expressed as a decimal. And then you can calculate Q the same way that you would have calculated P on the other side. with using the idea that P plus Q equals 1. Let's say instead that you're given a phenotype. Now if you think about the original Hardy-Weinberg equation, P squared plus 2PQ plus Q squared equals 1. Each of those parts of the equation refer to a genotype frequency. P squared is equal to the frequency of homozygous individuals, 2PQ is equal to the frequency of heterozygous individuals, and Q squared is equal to the frequency of homozygous recessive individuals. So most likely for my class, you're going to be given the recessive phenotype. And this is one of the easier ones to pick up on in the problem. If you're given a phenotype, you are going to determine which part of the equation you're given. Most likely you're going to be given the recessive phenotype, and so that is going to go along with the homozygous recessive genotype, because remember, if you have a homozygous recessive individual, they have the recessive phenotype. Thinking about it the other way, if you have an individual with a recessive phenotype, you always know their genotype. You know that their genotype is homozygous recessive, and so you can use that information to begin working on your problem. So if you have the recessive phenotype, then you are going to start by calculating Q squared. So you're going to set your recessive genotype frequency to Q squared. And this is, since it's a frequency, is calculated the same way that you calculate P or Q. You just have to keep in mind what you're going to be using. So if you need to calculate Q squared, you're going to count up the total number of homozygous recessive individuals, or the total number of individuals with your recessive phenotype, divide that by the total number of individuals in your population. So now you have the Q squared part of the Hardy-Weinberg equation. After that, you're going to use your Q value to calculate Q, or the frequency of that recessive allele. And you do this simply by taking the square root of your Q squared value. And then, once you have Q, you can calculate P the same way, using the equation that P plus Q equals 1. It's very unlikely that I'm going to give you a dominant phenotype to start off your calculations. I might, however, ask you why I don't do that. So for that question, you're going to want to refer to Lab 9. There's actually a question about that within your assignment. So then our last one, are you given an allele frequency? If you're given an allele frequency, the only thing you have to do here is decide if you've been given P or Q, because P and Q are both equal to allele frequencies. That's what they are. So if you're given an allele frequency, decide if you have the dominant allele frequency or the recessive allele frequency, and then use that to calculate the other. All of step 1 is determining what you have and calculating your P and your Q value. After that, you need to determine what else you need. So look at what you're given, use it to calculate P and Q. After that, you have to look at what the problem is asking you. Most likely, it is going to ask you for one of the genotype frequencies. To do that, you have to identify which genotype frequency you need. Which part of the rest of the Hardy-Weinberg equation do you need? Remember that P squared is the frequency of your homozygous dominant individuals. So if you're asked for the number of homozygous dominant individuals in your population, you're going to just plug in P and square it. If you're asked for something like the heterozygotes or the carriers, you're going to have to plug in 2 times P times Q and calculate that. Because you were likely given the Q squared in the beginning, you don't often have to calculate this one, but if it's part of the problem, then you need to do that. I find that step 2 is actually the easy part. Once you get your P and Q, it's really just plugging in to answer the question. And then finally actually answer the question. So another problem that students have is they just go through and they calculate everything, all the P's, all the Q's, all the squareds, all of that, and they don't actually answer the question, because they don't always need you to calculate everything. Look at what you're being asked for. If you have calculated everything, be sure to actually address the answer. If the question is asking what is the number of heterozygotes in a population, then you need to address that. Indicate somewhere that you know that that's the number of heterozygotes in a population.